My name is Mason Jupe, and today I'm going to talk to you about Plia liners. Plia liners are the most versatile and economical way to create secondary containment for any liquid need. The type of material can be varied to accommodate agricultural or industrial applications. Fertilizer, fuel, chemical, wastewater, just to name a few. With the help of some installation pictures, I'll show you some of the possibilities of the Plia liner. One of the most common applications is installing a Plia liner inside of a cracked cement containment. Regardless of the age or the extent of the cracks, if the cement hasn't fallen away, a Plia liner can long-term seal the containment area. Most cement treatments work short-term and need to be repeated. A Plia liner will last even as the cement continues to degrade. Pictured here is a 30-year-old cement containment that was cracked, leaked, and no longer worked for containment. The 45 mil Firestone polypropylene liner installed returned it to service. The cement in this installation was rough and the cracks were uneven, so this installation required geotech fabric underlayment pictured here. This fabric is a low-cost solution for protecting the liner from sharp edges and shifting concrete. Another existing concrete containment that was sealed using a polypropylene liner. Notice the upper and lower top plate that sandwich the liner, both attaching and protecting the installation. This installation also shows the sand tubes used as ballast to keep the liner from lifting away from sides and corners when high winds blow over the top of the installation. This concrete containment had an existing sump that you can see in the center of the containment floor. Existing sumps need to be measured so we can design/build prior to being on site. Standard sumps are 2 feet by 2 feet by 6 inches, but if we know ahead of time, we can adapt to any sump configuration. Sumps are installed after the liner has been secured using a hand leister. This installation was for petroleum products and the liner was XR5 made by Siemens Corporation. This liner was attached to the top inside of the wall using red heads and batten bar. You can also see it was attached to the tank bases in the same manner. Butyl tape or a specified sealing gasket is used to create the liquid seal. The yellow walkways seen in this install are mats made from XR5 material. They were hand leistered down when the liner was secured and they aid in slip-free movement inside the containment area. Another Plia liner application is for the new containment installs. By aligning or stacking large concrete blocks, you can create the necessary containment space and then use a liner to seal the area. The blocks can be obtained from local concrete companies and vary in size. The most common block size from our experience is 2 feet by 2 feet by 4 feet. When sizing a containment, it is best to allow 3 feet in between tanks and 3 feet between tanks and walls. This allows for plumbing and movement around the tanks. The floor for this type of containment should have 1 inch of fall for every 20 feet. The lowest corner will be used for the sump. You will want to level the walls, which means you will build up the surface under the blocks to compensate for the floor slope. The blocks used in this containment include a design stamp. We do prefer the inside surface be smooth, and we will use geotech material to compensate for any unevenness. This install has a beveled corner to allow semi-travel around the containment area. These blocks will vary in cost and there is also cost in trucking them to the site. In most cases, it has been a savings over other type of wall installations. The upper and lower plate configurations work well for attaching the liner. The lower plate is commonly secured with tapcons while deck screws are used to fasten the upper plate. One additional advantage to the large cement blocks is you can easily add to the containment size. Add additional blocks and we can seam additional liner to enlarge the containment volume. The large cement blocks work for larger containment areas. This containment is 3 blocks high and fits an irregular area but still satisfies the massive containment requirements of these large storage tanks. This picture shows that the tanks were built on pads filled with pea gravel inside of steel rings. For this installation, the liner was secured inside the ring, pea gravel was added, the tanks were built, and the liner was installed to the area outside the rings and connected to the walls. Another Plia liner installment is for agriculture chemicals. This liner is manufactured by Siemens Corporation and satisfies the requirement for secondary containment of most agriculture chemicals. When containment areas are inside buildings, often no sump or sand tubes are required. The containment area is often smaller as cone bottom tanks don't have as a significant displacement as flat bottom tanks. Another option for new containment installations is poured cement walls. This saves the amount of cement over a total cement containment as the floor is not necessary. When walls are established, the installation of liners can often be completed in a half day. In some areas, wood is approved to create the containment walls. This install is very similar in process to the cement block walls. The floor of inside containment walls is still recommended to have slope, but it is not critical to the project. With any surface that is uneven or has sharp edges, we recommend using geotech. Another application for ply liners is creating an earthen berm to use as the wall of the containment. In these installations, the size can vary from only requiring one panel to needing multiple panels welded together on site. For example, a 5,000-gallon fuel tank could be adequately contained in 20 feet by 20 feet by 2 feet earthen berm containment, while large fertilizer tanks could need a containment similar to the one in progress in this picture. This earthen containment is 120 feet by 60 feet by 8 feet and has a displacement of 430,000 gallons. This containment is part of a refinery and is utilizing XR5 material. This picture shows the liner entering into the ground at the top edge of the containment. We refer to this as the burial trench. You can see the burial trench in the foreground. This trench is 2 feet deep, 2 feet wide, and has 5 feet of liner buried under the soil to hold it in place. This is a wastewater project that has a burial trench at the top and batten bar fastening it to the concrete floor. Ply liners are the most versatile and economical way to create secondary containment for any liquid need. Please contact your Ply containment dealer if you have any questions or if you need a quote.